Okay, this is the last part of Section 6. What we are going to discuss very briefly is the NICO supports multi-node NVLink. So we know we can do peer-to-peer memory access for MNVL domains. But the fact is that, up to Section 5, we have been discussing NICO. Notably, we have discussed NICO in Section 4. And then in Section 5, we also discussed this NICO, how to use this NICO on the Nvidia systems. And up to now, what we know is that NICO can be used for an NVL domain. But what we know is that it's okay to be used with non-MNVL domains. Non-MNVL domains. NICO is okay to work with this kind of NVL domains. Now, the fact is that NICO also supports multi-node NVL domains, NVL link domains. So NICO also supports MNVL domains. And NVL72 is a kind of MNVL domains. Okay, so this NICO can be used with these kind of domains. It can work perfectly with this MNVL72. And then specifically on MNVL systems such as GB200, NICO will automatically detect the NVLink domains and identify which GPUs belong to them. It will then select the optimal settings and algorithm to maximize performance both within and between NVLink domains. Okay, so it works, no problem. And here, have a look at these documents regarding this user guide, regarding this MNVL. It seems it's saying that, but this MNVL, this NICO, it's not all the version of NICO works with this MNVL. Only NICO version 2.25.2 and later. Only this version and the later version supports this MNVL domain. Okay, but since version 2.21, it suggested that whenever you set up your NICO environment, it's better to enable NICO to use multi-node NVLink MNVL available. If the system or driver are not multi-node NVLink capable, then MNVL will automatically be disabled. You have no trouble. If it works, it works. If it doesn't work, it will be disabled. You won't have any trouble. Okay. But this feature also requires NICO put-down memory support, and that means this one needs to be enabled for this NICO MNVL and for this NICO MNVL support. Okay. Very interestingly, that here is mentioned that MNVL requires a fully configured and operational MX domain for all the nodes that form this NVLink domain. So we have just discussed that this MX support, this MX service is necessary for the functioning of this peer-to-peer multi-node memory access programming model. And this MX service is also necessary for this MNVL unequal support. Okay, so that's fine. Okay, MPI plus nickel, MPI plus MNVL's capable nickel is the other option to programming this kind of NVL72 system. So MPI plus NVL nickel is another one of the programming models for NVL72. So if you have these systems, if you have two NVL72 domains, and you are going to have this nickel communication within each domain. But then in between the two NVL domains, what you need to do is that pretty much you need to run this MPI. So I'm saying that MPI plus NVL as capable nickel is another programming model besides this MPI plus peer-to-peer memory access. Okay. The last point, the last question is just a question. So we can run nickel within the NVL domain, this NVL72 domain. We can have this peer-to-peer memory access. So we can have MPI plus nickel as one programming model. We can have MPI, maybe TCP IP plus peer-to-peer memory access as programming model, peer-to-peer memory model. We have one, we have two. We have these two options. But the MPI is always for communication between the NVL72 domains. Okay. My last question is that, is that possible? Do we have any interest to deploy this kind of MPI plus NVL capable nickel program plus peer-to-peer memory as the programming model for this kind of NVL72 systems, with multiple NVL domains? The reason for me to ask question is that for CPU computing, the most promising programming model right now is MPI plus OpenMP. So for GPU, the analogy of OpenMP shared memory programming, let's see. The analogy of OpenMP shared memory programming is peer-to-peer memory access, and MPI, the analogy of MPI for GPU computing is nickel. So do we have any interest to do nickel plus P2P plus peer-to-peer memory access as the programming model? And because nickel cannot function without the MPI, so pretty much we need to have this MPI plus nickel plus peer-to-peer memory access. So my last question is whether this one is possible, whether there is any interest or any benefit to do this for NVLink 72 systems, or for the future NVLink 144 systems, or for the NVLink 256 systems. This is my question. I have no answer. So my question is that why the MPI plus nickel plus peer-to-peer is interesting? Is it useful or not? Okay, and that pretty much is the end of the 6 sections of the series of slides. I hope you have enjoyed. Any questions, you can just let me know. Okay,